Hey there, I'm srcmake, and in this video we are going to go over the solution for IBM's Ponder This Challenge for April 2018. I've written an article that goes over the solution. If you'd prefer to read the article yourself, then go ahead and click the link below this video to get to this webpage. And if you stick around for this video, then we're going to go over the article together, and you'll probably get a better intuitive understanding of what's going on. So let's go ahead and get started. So the question for April 2018 can be found in this link. You can get to the official page, or you can read the question right here. But we're not going to read the question in this video. It's going to take a little bit of time. So we're just going to summarize the problem statement and go over the key points. So there are 9 distinct balloons, and each balloon has a different color, which means you can visually see which balloon is which. And each balloon has a different lifting capacity, which means it can lift a certain amount of weight. There is a 9.5 gram weight that we have that can be tied to one or more balloons, which will form a subset or an experiment. We'll use those words interchangeably. And for each subset/experiment, we must make it so that the balloons don't fly away, which means that we can't have a subset of balloons that weigh over 9.5 grams, because if it does, then the balloons will fly away, the weight flies away, and Alice gets mad. So that doesn't work. So what we want to do is we want to come up with a set of experiments to show Bob so that Bob knows what the 1 gram balloon is. The whole point is to make Bob figure out what the 1 gram balloon is through a set of experiments. So as an example of subsets we can choose the 1, 2, and 3 gram balloon. We can put them together to form a subset of experiment because those add up to 6 grams of lifting capacity, which won't weigh our 9.5 gram weight up. It'll stay down. But 2, 9 is not a valid subset because those balloons add up to 11 grams of lifting capacity, which will weigh the subset/weight up, and that is not good. So we can't choose that. So to begin our solution, let's think about what subsets we can actually choose for our experiments. So what's the maximum number of balloons we can have in a subset? That's a great way to start out. So can we have 4 balloons in a subset? Well, the lightest balloons we can choose for a 4-balloon subset would be 1, 2, 3, and 4. But those add up to 10 grams, which is over our 9.5 gram weight. So we can't have 4 balloons in a subset. The maximum amount of balloons we can have in a subset, which we saw before, is 3. We can have 3 balloons. So we saw 1, 2, 3 before, and that weighed 6 grams, which was lower, so that works out. And if you do a little bit of work, you can see that there are 7 possible 3-balloon subsets, which are right here on the page. You can have 1, 2, 3, 1, 2, 3, 4, etc., etc. These balloons all work out for 3-balloon subsets. You can also have 2-balloon subsets, of course. You can have the 8-gram lifting balloon and the 1-gram balloon. Those work out. The 7-gram balloon and the 2-gram balloon, etc., etc., for 2-balloon subsets. And obviously, each balloon can be weighed by itself because all balloons are under 9.5 grams of lifting capacity. So those are the subsets we can choose, and with those in mind, we want to come up with a set of experiments. So let's start out with a really simple example to show that we can do this in 6 experiments. So what we're going to do is we're going to take advantage of the fact that so we have 7 possible 3-balloon subsets, right? And in 6 of these, the 1-gram balloon shows up, and that's what we want to take advantage of. So no other balloon can show up 6 times in the 3-balloon subsets. For example, how many times does the 2-gram balloon show up in these possible 3-balloon subsets? Well, it can show up here, it can show up in these, but those only come up 5 times. It can't show up in these 2. But the 1-gram balloon can't show up 6 times, which means that if we show Bob these sets of experiments, these balloon subsets, well, he'll say, okay, there's this one balloon which has a certain color that shows up 6 times, and I've only been shown 6 different 3-balloon subsets. And the only way that's possible is if that particular balloon is the 1-gram balloon. No other balloon can do that. And so Bob knows that this particular balloon is the 1-gram balloon. So that's a really simple way to show Bob the 1-gram balloon, and we did that in 6 experiments. But can we do better than that? Well, the answer is yes. So we can do this in 5 experiments. And the way we want to do this particular experiment, the way we're going to think about setting this up, is we want to show Bob all of the balloons, all 9 balloons. And what we want to do is we want to exploit that we show that the 1 gram balloon does something that only the 1 gram balloon can do. No other balloon can do that. And to do that, we're going to make 2 key observations to help us out. The first is that the 9 gram balloon cannot form a subset with any other balloon. Otherwise, the total lifting power would be over 9.5 grams. So the 9 gram balloon can only be by itself. And the other observation we want to make is that the 8 gram balloon can only be paired with the 1 gram balloon. The 8 gram balloon can't be paired with the 2 gram balloon because that would form 10. It can't be paired with anything else, only 1. So we're going to exploit that to come up with another set of experiments. So we are going to show Bob this set of experiments, and we'll see that there's 2, 3, 4. So Bob sees 2, 3, and 4. And 1, 8, 1, 7, 1, 6, 1, 5. So in these sets of experiments, which Bob views as something like this with letters, because again, he doesn't see actual numbers, but he does see colors, which we're going to label with arbitrary letters. Bob sees 8 different colors in the experiments that he was shown, but he also knows that the 9 gram balloon wasn't seen in the experiment. So the one balloon that he didn't see in the experiment must be the 9 gram balloon that's off to the side that Alice didn't show him. And the reason he knows it's the 9 gram balloon is because it didn't show up and it can't pair with anything else. Everything else was able to pair with another balloon, which means that these balloons right here are definitely balloons 1, 2, 3, 4, 5, 6, 7, and 8 in some orientation. And Bob also knows that the 8 gram balloon is only able to be paired with the 1 gram balloon. It can't pair with anything else. So balloon D must be the 1 gram balloon, because balloon D shows up a bunch of times, and of course the 1 gram balloon can only be paired with 8. So regardless of E, F, G, or H, any one of those could be the 8 gram balloon, but it doesn't really matter. The partner balloon, which is D, which shows up multiple times, which obviously the 1 gram balloon can do, is the 1 gram balloon. So balloon D is the 1 gram balloon. So Bob knows what the 1 gram balloon is, and we did that in 5 experiments. So that's a pretty good answer, and I thought 5 was the actual answer. But it turns out that you can do this in 4 experiments. And it took a little bit of work, to be honest with you, and we're going to go through a process to see how this works out. But yeah, so there's a 4 experiment solution. We can do even better. And to find this out, we're going to combine some of the concepts that we used in the previous 2 solutions. So the first observation that we're going to make is that in the 3 balloon subsets, you remember the 3 balloon subsets, these are them right here, which is what we're going to use for this particular set of experiments. There are only 6 numbers that show up. You can see that 1 shows up, 2 shows up, 3 shows up, 4 shows up, 5 shows up, and 6 shows up. Those balloons show up in the 3 balloon subsets that are possible. To say this another way, you'll never see 7, 8, or 9 in a 3 balloon subset. Those balloons cannot exist in a 3 balloon subset. So we're going to take advantage of that. The other thing we want to take advantage of is that the 6th balloon can only show up in one of the 3 balloon subsets, which is 1, 2, 6. As opposed to this, other numbers can show up multiple times. For example, 5 can show up in 1, 2, 5 or 1, 3, 5. 4 can show up a bunch of times, and obviously 1, 2, and 3 can show up a bunch of times. But 6 can only show up in 1, 2, 6. And the last thing we'll take advantage of is that the 6 gram balloon can only be partnered with 1 and 2, can't be partnered with any other balloons. So with these in mind, what we want to do is we want to come up with some set of experiments, and we want to prove that the 1 gram balloon can only be the 1 gram balloon, that no other balloon could be the 1 gram balloon, which is a bit of a trick. So let's say we do show Bob 1, 2, 6, and he recognizes 1, 2, 6. Well, what we need to do is we need to prove that the balloon color, which is 1, can only be 1 and it can't be 2. And I know this sounds a little bit vague, it's a little bit sketchy right now, but we're going to go through the solution, and then we're going to go through the proof. And then I'm going to show you how I actually came up with this. So we'll show Bob these balloon experiments. We'll show him 1, 2, 4, 1, 2, 6, 1, 3, 4, and 1, 3, 5. So this is our set of experiments, the 4 balloon subsets that we're going to show Bob. And Bob sees this as ABC, ABD, AED, AEF. Again, Bob just sees colors, but we're just arbitrarily labeling these numbers with letters so that we can play around with it a bit better. So let's actually go through the picture. You could read this yourself if you're reading the article, but let's do this through the picture. I'll just explain it for you guys. So this is the set of experiments that we showed Bob, and obviously we convert these to generic lettering. So Bob sees one is A, which maybe stands for aquamarine. That's the color he sees. He sees balloon B, which could be, I don't know, blue or something like that. And what we want to take advantage of for what Bob sees is we're going to walk through some logic. So the 6-gram balloon can only show up once, right? So the only letter that shows up once are, what is it, D and F. D and F show up one time. So one of those has to be the 6-gram balloon. So let's break off into two possibilities. Either F is the 6-gram balloon or D is the 6-gram balloon. That's the only possible choice for it, right? So we'll fill in 6 as F in our first example, and we'll fill in D equals 6 in the second example. So this is what the subsets must be possibly to Bob. So 6 can only be paired with 1 and 2, right? So for this particular example, either A is 1 and E is 2, or A is 2 and E is 1, right? Because that's the only possible matchings with 6. So we can try both of those, and if A is equal to 1, we're fine with that. Okay, A is equal to 1, that's what we want to prove. But if A is equal to 2, that would be an issue because that would prove that Bob can't recognize that A is a 1-gram balloon. We want to prove that A can only be 1. So we'll fill in A equals 2, and we'll fill in E equals 1 for this possible subset for what Bob might expect it to be. And then from there, we'll try, we still need the 3, 4, and 5-gram balloons to show up for balloons B, C, and D. And we can try all those possibilities, which means that we could try B equals 3, C equals 4, D equals 5. We could try B equals 5, C equals 3, D equals 4, etc. But once you fill those in, you're going to find that there's an issue. So for this particular example, for the subsets Bob sees, F equals 6, A equals 2, E equals 1, B equals 3, C equals 4, D equals 5. That's the total letterings. And if that were actually true, then that would mean that Bob saw 2, 3, and 5 in one subset. But that adds up to 10. That is over our 9.5 weight. But this subset didn't fly away, right? So this is impossible. So this possible lettering is impossible. And if you keep going through examples like those, you'll see that each of these end up being impossible, which all leads back to A cannot be the 2-gram balloon. And if you go back to D equals 6, you'll also see that A cannot equals 2 because, things go wrong. So with that, we prove from Bob's perspective that A can only be 1. So Bob knows that A is the 1-gram balloon, and that is, just the proof. So how did we come up with this? I brute forced this with some code because I was trying to do this by hand, and to be honest with you, I was getting a bit annoyed because it kept failing, so I just wrote a program to do this for us. So I wrote some C++ code. I'll quickly go over the code logic. So given all the valid 3 balloon subsets, which we know there are 7 possible ones, which are right here, try picking 4 of these experiments to show to Bob. So for example, we'll show Bob these 4 in one possible program, and once that in one try, we'll show him like these 3 and this one, and we'll just choose 4 of these. We'll try all possibilities, and we want to make sure that all 4 of the experiments have all the balloons. We need to make sure we see 1, 2, 3, 4, 5, 6, because that's what we want to exploit in this possible in this set of experiments. Then we want to convert those experiments to generic lettering, which means 1, 3, 5 becomes ACE. Then we want to calculate all lettering possibilities. So for example, you saw how F equals 6, A equals 2, E equals 1, B equals 4, C equals 5, D equals 3. That was one possible lettering possibility. We want to calculate all of those possibilities. And once we have that, we want to try the 4 experiments that we chose with the lettering possibilities. And if the experiment showed that A equals 1, that A has to be the 1 gram balloon, it cannot be any other balloon, then we output the results. And it's some pretty bad code, to be honest with you. I honestly, I wrote it really prettily, which means it was 250 lines of code, and I'm going to copy it and I'm going to run it right now just to show you. But it's a little bit unoptimized because honestly, this isn't like, there isn't that much. I'm just going to copy and paste it and run it really quickly. Yeah, I don't know. I keep messing this up. Come on, click properly. So there actually aren't that many choices to do. So we'll say bash and we will make the code, and you'll see that the output is this. There weren't that many experiments, so there was no point in optimizing it this month because we did a lot of the work beforehand. There are only 9 balloon types, and there's only so many possible combinations, etc. So it's actually really no numbers. So we actually come out with 2 possible experiments. Ignore this. I just wanted the lettering for, you know, easiness. But there are actually 2 solutions for this. And of course, if you go through this same process for the second solution of trying to prove that 1 has to be the 1 gram balloon and can't be any other balloon, that you'll see that the answer exists. So we do show that Alice only needs to show Bob 4 experiments if you show him either this experiment or this experiment. And that is our solution for the IBM Pondered This Challenge for April 2018. I was a little involved, but I just wanted to show what the process of thinking was and how we actually came up with the solution. So if you like this video, go ahead and hit the subscribe button below this video, and we'll try to solve more IBM challenges each month and do other cool programming stuff. So I'm srcmake. Thanks for watching. That was IBM's solution for April 2018.